Right. The question number 7 of the truths given on Thursday. It is asking about electron configuration of copper 2 plus ion. You can write it. Part A. Part 2. State the color of compound NCl2. Right. But you need to understand both ferrous chloride, anhydrous, cuprous chloride are in yellow brown color under anhydrous conditions, solid under anhydrous condition, yellow brown color, right? That is their color without water. But with water, all copper salts are typically blue colors. It become blue, right? So color of MCl2 is what? Yellowish brown. Then the color of MCl2 turns into yellow when treated with concentrated HCl. Concentrated HCl then the solution turns colorless, forming MCl2 minus when sulfur dioxide is passed through the solution. So what kind of reactions can take place here? Let's see. Here you have copper 2 plus. Copper 2 plus. Or you have CuCl2 solid. Upon the addition of concentrated HCl, right, it turns CuCl4 2 minus 8 plus. This is the species responsible for the yellow color, right? It is the species that responsible for the yellow color. CuCl4 2 minus, it is yellow, right? Then what can happen when sulfur dioxide is passed to the solution of copper 2 plus? Here you need to understand, in that case, copper 2 plus ions being reduced by sulfur dioxide to copper 1 plus ion, Cu2 2 plus, cuprous ions, and sulfur dioxide turns to sulfate. So the initial blue color of the copper 2 plus solution get colorless. Right. This reaction can be used as a test for the sulfur dioxide gas. This reaction can be used as a test for the sulfur dioxide gas. Here the sulfur dioxide decolorized the copper 2 plus solution. Right? This thing I was given in your anion identification part. In the anion identification part, I mentioned about this reaction. There we have two reactions to identify sulfur dioxide. First one, sulfur dioxide decolorize the colored flower petal due to its bleaching properties. Sulfur dioxide can decolorize colored flower petal due to the bleaching properties. This is the second reaction. This is how you can identify sulfur dioxide by using copper 2 plus ion. So this question is based on this theory part. So always you need to know when the question is asked in inorganic. So where did you learn about that in your theory classes? Okay, so that is the problem for the most of the students. They don't know where they learn about that. Right? Here this is regarding to the identification of sulfur dioxide. Right? Right. Now we are going to learn how to apply this phenomena to this question. Right? It says color of MCl2 turns into yellow when treated with conc HCl. The resultant solution turns colorless, forming NCl2 minus, right? When sulfur dioxide is passed through the solution. Right. So these are the reactions. Now let's see. You have CuCl4 2 minus. CuCl4 2 minus plus sulfur dioxide. So sulfur dioxide goes to sulfate and CuCl4 goes to CuCl2 1 minus. This is the unbalanced reaction. You can balance this 2. Yes. This is the reaction. Ionic reaction. This is colorless. This is blue. Sorry, yes. This is yellow. This is colorless. Here, 2 electrons are transferred. Here you have copper 2 plus. Copper 2 plus, you have copper 1 plus. So the difference is 1. That's why I multiplied this with 2. Understand? Okay. This is the reaction. Then identify the chemical species responsible for the yellow color. It is CuCl4 2 minus. You can write the answers with copper 2 plus also, because the atomic number 29 is copper. What is the role of sulfur dioxide? Sulfur dioxide behaves as reducing agent by reducing copper 2 plus to copper 1 plus. Briefly explain why MCl2 is colorless. You know the answer, because in D block we learned that cations having D0 and D10 configuration are not capable of showing any colors. So, because why? So the copper CuCl2 minus is colorless. Because why? Right? The problem is, for them, they don't have vacant d orbitals. They don't have vacant d orbitals for the dd transition. Okay, let's see how we can explain that. Initially, now I am going to explain the theory regarding to the color of the d block cations. So listen carefully. There we have 5 d orbitals. Like this. Right? Their energies are identical. So we call them as degenerate energy levels. Degenerate. Right? Here, due to 2 reasons, these degenerate d orbitals. Degenerate d orbitals splitted to 2 energy levels, like this. Like this. This phenomena is said to be as crystal field splitting. What? Crystal field splitting. This crystal field splitting is due to two reasons. First one, shape of the coordination complex that about to form. Second one, relative shape of the d orbitals. Here you don't know, no need to know about those things in details, but it is enough to know due to two reasons the crystal field splitting take place. Right? Sorry, due to two reasons splitting of d energy levels take place. Those are shape of the d orbitals and shape of the coordination complex that is going to form. Right? So the separation of d orbital like this is said to be as crystal field splitting. Crystal field splitting. Right? Read the theory parts for details. Right. Now think, there you have one electron in the lower d energy level. Generally, this lower d energy level is said to be as T2G level. T2G level, and higher energy level is EG level. EG level and T2G level. Now think, when white light transferred, when white light goes through the cation with splitted d orbitals, so some frequencies in the visible region being absorbed by this electron. As a result of that, this electron goes to upper energy level like this. So this phenomena is said to be as DD transition. Learn it. DD transition. This phenomena is said to be as DD transition. Then the transmittance white light. What is the meaning of transmittance white light? When white light goes through the cation like this, some frequencies are absorbed. Then the white light coming from the cations. That is transmitted white light. The white light coming from the cation is lack of these frequencies that they absorb. Therefore, they can show some color. Again I explain. When white light passes through the cation like this, lower electron can absorb electromagnetic radiation relevant to the visible frequencies. Therefore, the light emitted from the cation do not contain that kind of frequencies. Because of that, they can show the remaining color. Right? So this phenomena is said to be as DD transition. In brief, you need to understand D block cations can make some colors due to two reasons. Briefly, crystal field splitting followed by DD transition. That's all you need to know. Crystal field splitting and DD transition. So they are asking about, in that question they are asking why they can show color. So the answer is, you can write, why Q plus chloride is colorless. Right? For the Q plus ion, electronic configuration is D10. D10 means what? All these shells are filled with electrons. Therefore, it is not possible to carry out DD transition. So what is the answer for the question is like this. Since copper 1 plus has D10 configuration all d orbitals are filled with electrons, 2 electrons each. Therefore, it is not possible to undergo dd transition when white light is absorbed. That all. Right? That is the answer. Okay? Okay. Yellow color of the species X in part 2 above turns into blue color in dilution. Write down the relevant ionic equation for this observation. Yes. The reason is this one, formation of this. The reason is formation of copper aqua complex CuH2O 6 2 plus. This is blue in color. This is blue in color. That is the reason. Right? So, this is the equation Cu This is the equation CuCl4 2 minus plus water CuH2O 6 2 plus. You can put here 6 4Cl minus. This is yellow and this is blue. This is the expected answer. Right? It is the expected answer. Okay. Then the B part. A is a white solid. It reacts with dilute sulfuric, liberating the colorless gas B and giving a clear solution. A is a white solid. It reacts with diluted sulfuric, liberating the colorless gas with colorless gas B and giving a clear solution C. When gas B is passed through the solution of acidified potassium dichromate. Right. Here, you need to know what kind of gases can be evolved upon the addition of sulfuric acid. The possible gases are upon the addition of dilute sulfuric, right? Addition of sulfuric. The gases are carbon dioxide, nitrogen dioxide. This is colorless, odorless gas. This is the only red-brown gas we know. One of the red-brown gas, other one is Br2, but Br2 can't evolve upon the addition of sulfuric. Nitrogen dioxide also have pungent smell. Then the sulfur dioxide, colorless, pungent smell gas. H2S, colorless, pungent smell or organic smell. These are the main kind of gases that can be released upon the addition of sulfuric acid into the particular organic salt. So, in presence of carbonate ions, they produce carbon dioxide. The reactions, carbonate, H plus, carbon dioxide, nitrite, H plus, nitrogen dioxide, red brown color, sulfur dioxide, H plus, sulfite, H plus, sulfur dioxide, sulfite, H plus, H2S. Right. So, the liberation of these gases are relevant to these anions. Understand? Okay. So here colorless gas, that means nitrogen dioxide can't evolve here. So it may be carbon dioxide, sulfur dioxide and H2S. Right? But the gas won't be a carbon dioxide. Because why? Carbon dioxide can't make orange dichromate green. Right? So because the dichromate, in order to dichromate undergoes Cr3+, there should be a reducing agent. Reducing agent has to be oxidized. In the carbon dioxide, carbon is at its maximum oxidation number. Right? So it can't be oxidized further.